Welcome, this is Dan. Our first problem set, taken from the textbook. Make a little asterisk here. This is the textbook I pulled this problem from. Brown and Others, Chemistry, Central Science, 12th edition, 2012. Taken from chapter 1, about matter and measurement. Don't be intimidated, we're still getting used to chemical structures. This might even be your first introduction. You'll learn there are different types of elements associated with different atoms. Here, getting used to the concepts, they pose us the question, how many carbon atoms are in one aspirin molecule? You might be familiar with aspirin, buy it at the pharmacy, grocery store, etc. Also, the questions phrased here in the text. I typed it up above for clarity. So we note the structures. We have oxygen, water, carbon dioxide, ethanol, ethylene, glycol, and lastly, the big kahuna there, aspirin. We don't really need to know anything about how these atoms connect. Nothing deeper than just knowing what's told in the legend. That white represents hydrogen, red, slightly larger, represents oxygen, black, slightly larger, represents carbon. That's just the scheme they present us with. We're also told that same information without the pictures there in the figure title. White, black, and red spheres represent atoms of hydrogen, carbon, and oxygen, respectively. It's a little annoying. In the key it goes hydrogen, oxygen, carbon. In the figure title there, it goes hydrogen, carbon, oxygen. I like when they're consistent. Nonetheless, we only need to look at aspirin. Again, we're not worried about how these atoms connect, what types of bonds stick the two atoms together. We're only interested in determining how many carbon atoms would you find if you looked at the structure of aspirin. And they give us this funky representation. This is called a space-filling model, or a space-filling representation. See these pretty frequently. We'll encounter these throughout the rest of the textbook. So I'm going to use a check mark notation just to keep track as I go through the structure of aspirin, looking for the black spheres for carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, to answer our question, there would be 9 carbon atoms present in aspirin. You could also say that as 9C, with C being the chemical symbol for carbon. And there we have it.